Welcome to this video tutorial on converting out of parametric equations and into our typical rectangular form. We are going to look at two problems in this tutorial. The first is pictured on the screen. Now ideally what we're going to do is graph these after we have converted them into rectangular form. So the way we typically begin with converting into rectangular form is we pick one of the equations. Typically it's going to be the x, but it could be the y. And we're going to solve for t. So in this case we will have x plus 1 divided by 2 is equal to t, once we isolate t and get it by itself. Then what we're going to do is we'll take that expression for t and plug it into our other formula. So here y is going to turn out to be equal to 4 t squared plus 5, where we plug in that t is x plus 1 all over 2. Now we can simplify this a little bit because this will turn out to be y is equal to 4 times, we square both the numerator, x plus 1 squared, and we square the denominator, we get a 4. Notice the 4's are going to cancel there. So for our rectangular form, we're going to have y is equal to the quantity x plus 1 being squared plus 5. If we were then asked to graph this, this would be a parabola opening up. There's our parabola opening up. It would have its vertex point at -1, 5. And then the other things that we have indicated we would want to see on the graph are the point where t is equal to 0. So if we plugged in 0 for t into x, we would get -1. If we plug in 0 for t into y, we get positive 5. So this is the point where t is equal to 0. We will label that. And then in which direction is this graph drawn? Well, as t gets bigger, x is going to get bigger. So this graph is going to be drawn to the right, and it's going to be like that. Of course, back over here on the left, this would be a point perhaps where t is equal to -1, where t is equal to -2. So as t gets larger, this graph draws from left to right, and this spot is where t equals 0 would fall. Let's turn our attention to one that's perhaps a little bit more triggy, shall we say. Here's our next example. Now in this case, what we're going to do is we're going to get sine and cosine by themselves. So for x, we have that x minus 7 all over 2 is going to equal the sine of t. And really what we want is we want to square both sides of that equation. And then for the y equation, we will have y minus 5 all divided by a -3 is equal to cosine of t. And again, we're going to square that equation. The big idea for these types of problems is our favorite trig identity, or quite possibly our favorite trig identity, that sine squared plus cosine squared is going to be equal to 1. So when we add up these two equations, sine squared plus cosine squared is 1, and then we're going to have x minus 7 all over 2 squared plus y minus 5 all over -3 squared is equal to 1. Let's manipulate this just a little bit. This turns out to be x minus 7 squared all over 4 plus y minus 5 squared all over 9. When we square a -3, we get positive 9 is equal to 1. And this is going to be an ellipse. Nice. It's going to be an ellipse with a center point at 7, 5. Remember back down to our review here, where for an ellipse, this is the amount it's going to go left and right, which will be 2. This is the amount it's going to go up and down, which will be 3. So this is going to be actually a vertical ellipse. Let's get a vertical ellipse drawn on our page. That's decent. I guess that suffices. The center point is at 7, 5. We go up 3, so this will be 7, 8. We go down 3, so this will be 7, 2. Then we go left and right 2, so we get 9, 5 and 5, 5. Now remember our focal points here for an ellipse. It was that a squared is equal to b squared plus c squared. The a in this case is going to be 9. 9 is equal to 4 from here plus c squared. So c squared is equal to 5, or c is equal to plus or minus square root of 5. So our focal points are going to be up square root of 5, which would be 7 comma 5 plus radical 5, and down radical 5, which would be at 7 comma 5 minus square root of 5. What else? Well, we need where is t equals 0. So if we look back up to the top of our problem, to the original equations we were provided, x of 0, sine of 0 is just 0, so x of 0 is 7, and y of 0, well, cosine of 0 is 1, 5 minus 3 is 2. This right here would actually be the point formed by t equals 0. Now, is it going to draw to the left or to the right as we go? Well, if we want to figure out whether it's going to go to the right or to the left, we have to look at x. As t gets bigger, sine of t is going to increase, which means that x itself is going to increase and go to the right. So as we draw it, there we go. Now, the other way that you could opt to look at this is to think about what is the next key value for trig that we would plug in, and that would be pi over 2. So if we plugged in pi over 2, x would be 9. And if we plugged in pi over 2 for y into this equation, let's see, pi over 2, 0, 5. And then that would be over here, hence we would be drawing to the right. So when we have trig functions creep up in parametric equations, typically we like to isolate the trig functions and look for our Pythagorean identities, like sine squared plus cosine squared equals 1, and adapt it accordingly. Often it'll be one of our conic sections, a circle, an ellipse, or a hyperbola that will emerge.